When it comes to stellar corpses, there are three main types: black holes, white dwarfs, and neutron stars. Each one has their own extremities. Let's start with the white dwarfs. White dwarfs form when stars with a similar mass to the Sun reach the end of their giant phase, shedding their outer layers in a planetary nebula. What's left in the middle of this planetary nebula is a white dwarf, the former core of the star, about the size of Earth but as massive as the whole stars. Because of this extreme mass for something the size of Earth, its density and therefore gravity is extremely strong, about 400,000 times that of Earth. Their temperature is roughly 100,000 Celsius or 180,000 Fahrenheit. However, although they're extremely hot when they're formed, white dwarfs are actually quite stable, with no unexpected flares or storms. Combine that with their relatively small size, white dwarfs are a pretty good candidate for life in the long-term future. However, they take extremely long time for their heat to finally escape into space. And for obvious reasons, we haven't discovered any black dwarfs yet. So we'll probably just need to accept that we're never going to find any black dwarfs in time. Next up, we have the neutron stars. Neutron stars form when stars about 10 to 15 times the mass of the Sun explode in a supernova. What's left is a neutron star. It's only about 20 kilometers or 12 miles when it forms. That's like the size of New York. Yeah, it's so small, the Earth next to it is so low quality. However, it has the mass of the entire Sun. This means its gravity and density is extremely strong. Not just hundreds of thousands of times that of Earth. No. It's 100 billion times stronger than Earth's. Neutron stars have a temperature of roughly 1 million degrees Celsius or 1.8 million degrees Fahrenheit. They warp space-time around them, meaning you can see the front and parts of the back. There are three main types of neutron stars. Actually, four if you include a hypothetical one. Normal neutron stars that exist, pulsars, which spin extremely fast while emitting jets of radiation through their poles, magnetars that release a very strong magnetic field, about 100 trillion times stronger than Earth's, that would just disintegrate us, and a blitzer. It's a hypothetical neutron star that has to do with a pulsar slowing its rotation enough to the point where gravity collapses it into a black hole. Speaking of black holes, last up are the black holes. Black holes form when stars about 10 to 25 times the mass of the Sun explode in a hypernova, much stronger than a supernova. What's in the middle of this hypernova is a black hole. And things calm down. Black holes usually form about 30 kilometers or 60 miles in diameter. You also notice that there's an accretion disk around this black hole. They can form whether eating stars or collecting gas from their surroundings. These black holes, when they form, are called stellar black holes, one of four main types. Regular stellar black holes, which are pretty tiny, only a few times the mass of the Sun. Intermediate black holes with a few thousand solar masses, about a lot bigger than Jupiter. Supermassive black holes, which are in the center of galaxies, consuming a ton of matter around them, and ultramassive black holes, otherwise known as quasars, in the center of galaxies, eating the stars around them, which could be dormant millions of years later. Black holes get their name because they absorb all light, which make them completely black inside. Everything that is orange and that is inside of the orange part is the event horizon, and the gray part is a shadow. Everything else is the ergosphere, where things can orbit. Light is actually so severely bent that the accretion disk seems to go all the way around the black hole. But if you look at the top, it looks like this. Why is that? It's the way the black hole bends the light so severely. All of these come from a star, just like you.